Howdy everyone, my name is Eden Schlink. I'm an electronic systems engineering technology major here at Texas A&M, and I'm going to show you how to build your DIY Lightwave communication kit by Dr. Ekin. To get access to this video or more detailed instructions, please scan the QR code found on your kit. Before we get started, I'd like to actually demonstrate how your kit works. So as you can see here, I'm playing a song on my cellular device, which is hooked up to my transmitter, and then this is my receiver. So if I go ahead and turn on my transmitter here, we see the LED light up, and if we look carefully, we'll actually be able to see it blink. So basically what's happening is that we're converting our song into light, which then gets picked up by our solar panel and converted back into sound through our speaker. So if I go ahead and turn on our receiver, we should be able to hear our song. And if I were to block our transmitter, our receiver no longer receives our signal, so we can no longer hear our song. The cool part about your kit is that you have several different LEDs, so you can see how it affects the signal or changes the sounds that might be. On the inside of your kit, you can find a list of all the parts you'll need and the 2 wiring diagrams for your transmitter and receiver, and then a QR code if you need any further detailed instructions. So we're going to go ahead and get started on our transmitter. Okay, so here's everything you're going to need in order to build your transmitter. I would go ahead and cut this sticky square in half, that way you can use the other half for the receiver later. So we have our LED of choice. I went with an infrared LED so you can't actually see it with the naked eye. We have our audio plug and our audio amplifier, and then we have some jumper wires, our screwdriver, and our battery pack. So if you went ahead and added your batteries to your battery pack, that is fine. Just please make sure that it is turned off to prevent any shorting while we're building their transmitter. It's also very important that we do not mix up these 2 wires. Red is positive and black is negative or ground. If we do flip the wires, we will burn up our audio chip and let out the magic smoke. Okay, so looking at our wiring diagram, we can start with our audio plug. We have left, right, and ground. We're only concerned about right and ground. So I'm going to go ahead and place our jumper wires into those 2 terminals and make sure they're nice and snug. Go ahead and do a little pull test. Make sure they're secure. So it looks like my right will be my yellow wire and my ground will be my orange wire. So now we're going to our audio amplifier. If we look carefully, we can see that each terminal is labeled. We have audio, 2 to 5 volts, and ground. If I flip this to the other side, I can actually see positive audio and negative audio. So our right from our audio plug is going to go into the positive, and our ground from the audio plug is going to go into the negative. So make sure when you flip it over, you remember it's on this side. So our right goes to positive, and our ground goes to negative. All right, give a little tug test. Awesome. Okay, so now we can hook up our battery pack. So like I said before, we do not want to let out the magic smoke, so please make sure that these go into the right terminals. So looking at our audio plug, we see 2 to 5 volts, and then we see ground. So we're going to put the red wire into the 2 to 5 volts. And our black wire into the ground. Okay, awesome. Give it a little tug test, nice and secure. So last but not least, we can now add our LED. So an LED is also known as a diode. It has a cathode and anode. The positive side, or known as cathode, is the longer one. So if I go ahead and look at our audio amplifier again, and I flip it over, we can see that this side is positive and this side is negative. So when I flip it back over, we'll make sure that the longer part of our diode goes into the positive terminal. All right, I can make sure that's tug. Awesome. Okay, so now what we can do is use our adhesive to complete the project. So if I take this side off, really put up a fight. Okay, so I find it easier if you have your switch upwards, and I place the sticky pad here. Now what I can do is I can take our transmitter portion, wrap it around, and place it on top of that sticky pad. That way your wires are out of the way. You also have some zip ties and things to use in your kit if you want to make it any neater. Okay, so that is your transmitter. Let's move on to the receiver. Okay, so here's everything you're going to need in order to build your receiver. We have adhesive, a 2-pin male header, our solar panel, a female audio plug and jumper wires, our handy dandy screwdriver, our audio amplifier, our 4-ohm speaker, and our battery pack. I went ahead and hooked up the battery pack just to reiterate that it is very important that we put the red wire to the 2 to 5 volts and the black wire to ground. If not, we'll burn up the chip. Also, if you already put your batteries in, just make sure that the battery pack is off. Okay, so now looking at our receiver diagram, we can actually put in our solar panel. So if we look on this side, we see positive and negative, red and black. So looking at our audio amplifier, we have audio and audio. Turn it upside down, we see our plus audio and our minus audio. So we're going to put the positive side to the plus and the black to the negative. So red goes to plus, black goes to negative. Make sure it's in there. Awesome. Okay, so now you have 2 options for your output. We have this female audio plug and jumper wires. Using this basically allows you to use your external headphones, or maybe if you have an external speaker that you would like to use with an audio jack. For now, I'm going to actually use our 4-ohm speaker for this build, but you do have an option for this. All you're worried about is the left and right, and it doesn't matter which side it goes on your audio amplifier. So for the 4-ohm speaker, you have this little plug. In order to expose this little plug, they gave you a male pin header. So you're welcome to just shove it into the little holes, and now they are exposed. So now what we can do, it doesn't matter which side, as long as they go into our output terminals. Okay, make sure it's nice and secure. Alrighty, so now we can properly adhere these two pieces together here next. So to put everything together, I find it easiest if you place the solar panel face first and fold down the wires out of the way. Now what we can do is take our sticky pads, take our battery pack, and we want our switch facing up because it's a lot easier to deal with, and go ahead and place that sticky pad to the back. We will place it off to the side on our solar panel. Kind of want to leave some space in the middle just so you can put all these wires nice and neat, and your audio amplifier in the middle here. Now with our 4 ohm speaker, I like to leave the wires on top so it's easier to manage later. And then again, move the wires out of the way and keep it off to the side. Awesome. So now what we can do is we can grab our wires and kind of fold them in on themselves. And you have zip ties and stuff you're welcome to use. For me, I'm just going to leave it untied, kind of place everything in the middle. Now we're able to stand it up and use it for our demo. Okay, so let's see how well we did. So again, I have my phone here playing a song. You'll get one of these dongles in your kit, either for Lightning or USB-C. I have one for USB-C. Then I'm going to plug that into my audio jack. And now I can turn on our transmitter. And now let's see the moment of truth. As you can see, it does work, which is awesome. The infrared light is really hard to see. It also, you can tell that it passes through my hand a little bit, still playing some sound. But again, play around with the LEDs, find what works best and all the interesting different combinations you can make. And have fun. Thanks and gig 'em.